Hi guys, you are welcome to my channel. Today's topic is going to be about chemical formulae and IUPAC nomenclature of inorganic compounds. Chemical formulae and IUPAC nomenclature of inorganic compounds. In today's topic, we are going to learn about how to calculate the oxidation number of an element in a compound. You learn about calculation of oxidation number of an element in a compound. So let's look at chemical formulae. Chemical formulae is the composition of elements by the use of chemical symbols and numerical substrates. Is the combination or the composition of elements by the use of chemical symbols and numerical substrates. Then what is IUPAC? IUPAC means International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. Standard way of naming inorganic compounds according to International Union of Pure and Applied Chemistry is called IUPAC nomenclature. IUPAC nomenclature. So today's topic will be classified into two parts. Today's topic will be classified into two parts. The first part is naming of binary compounds. Naming of binary compounds. We are going to discuss about naming of binary compounds. The naming of binary compounds is further classified into two. Number one is naming of ionic compounds. Naming of ionic compounds. Then number two is naming of covalent compounds. Naming of covalent compounds. So in today's topic, we discuss about naming of binary compounds. Then what is binary compounds? Naming of binary compounds. So what are binary compounds? Binary compounds are compounds that consist of two atoms. Binary compounds consist of two atoms, whereby one is what is metallic. So when you are talking about ionic compound under binary compound. So we have ionic compounds. Ionic compounds consist of what? A metallic atom and a non-metallic atom. Ionic compounds consist of what? Of a metallic atom and what? And a non-metallic atom. Then, when we are talking about naming of ionic compounds, a naming of ionic compounds, the metallic atom will be named fully. You name the metallic atom fully, while the non-metallic atom changes to ide. The metallic atom, so ionic compound consists of a metallic atom and a non-metallic atom. So the metallic atom, the metallic atoms, or the metallic atom is named fully. Is named fully. Why the non-metallic atoms? Why the non-metallic atom changes to ide. So the metallic atom will be named fully, while the non-metallic atom changes to ide. So let's take examples, e.g. sodium and chlorine. So the combination of this compound is the combination of sodium and what? Chlorine. That is, the chemical symbol for sodium is Na, while the chemical symbol for chlorine is what? Is Cl. So sodium is a metal. Sodium is a metal because it carries what? Positive charge. It carries positive charge. So sodium is a metal. So you name sodium fully. Then chlorine is a non-metal. Chlorine is a non-metal. So the non-metallic atom changes iod. So instead of calling it chlorine, it will change to what? Chloride. 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 So the name of this compound is called what? Sodium chloride. Sodium chloride. So let's take another one. So what are we going to call K2S? What are we going to call K2S? K is what? A symbol for potassium. K is symbol for potassium, while S is what? Symbol for sulfur. So potassium is what? Is a metal. Potassium is a metal. So you name potassium fully. Potassium. Then sulfur will now change to what? It will change to iod. Sulfur will change to iod. So we call it sulfide. Sulfide. So the first atom, which is a metallic atom, will be named fully, while the non-metallic atom what? Changes to iod. So let's take another example. Let's take another example. NGO. NGO is the combination of magnesium and oxygen. Mg is what? Symbol for magnesium, while O is what? Is a symbol for oxygen. So we name the first one fully because magnesium is what? Is a metal. So we name it what? Magnesium. Magnesium what? Then oxygen will sound what? Iod. That is, oxygen changes to iod. You call it oxide. Magnesium oxide. Magnesium oxide. Now let's talk about ionic compound of what? Of transition elements. Ionic compounds of transition elements. So the first one is ionic compounds of group 1 to 3 elements. So B is ionic compounds of transition elements. Ionic compounds of transition elements. So when you have a binary compound of transition elements, when you have a binary compound that consists of what? Of a transition element. The transition element or the transition metal will be named fully, then followed by the oxidation number of that transition element. You name that transition element, then followed by the oxidation number of the transition element. So while the other element, which is a non-metal, changes to iod, you still follow, but you name the oxidation number of that transition element. So let's take for example, e.g. Fe2O3. Fe2O3 is the combination of two atoms, two different atoms, that is Fe and O. Then Fe is the symbol for what? For ion. Symbol for ion is Fe, while the chemical symbol for oxygen is O. So it's the combination of two atoms. Now Fe, which is ion, is what? Is a transition element. So you name these transition elements fully, followed by the oxidation number of these transition elements. So you have to calculate out the oxidation number of transition elements. So let's start. So you name Fe, which is what? Ion fully. Then calculate out the oxidation number of what? Of Fe from this compound. Now, how many Fe do we have? That's 2. So 2 times Fe will give me 2Fe. Then what is the charge on oxygen? What's the charge on oxygen? That's 2 minus. That's the number of valence for oxygen. Valence of oxygen is -2. So -2 times 3 will give me -6. Now let me explain how we derive this valence. Oxygen is in number 8. Oxygen is in number 8. Now, to write the electronic configuration of oxygen in ratio form, that will be 2:6. That is 2 plus 6 will give you 8. Then don't forget that the second shell will carry what? The maximum of 8 electrons. The second shell, according to our what? Electron distribution. The second shell will carry maximum of 8 electrons. So it needs, now this one, it needs what? It needs 2 electrons. It needs 2 more electrons to balance what? That 8, to balance that octet structure. So therefore, the charge on oxygen is what? Is 2 minus. That is how we derive the charge on oxygen. So minus 2 times 3 will give me minus 6. Will give me minus 6. Then equal to, everything equal to 0. Everything equal to 0. Then 2Fe then will be equal to, move this minus to the other side, we change to what? Plus 6. Then divide both sides by 2. Fe will be equal to 2 here 1, 2 in 6 will give us 3, so plus 3. So the oxidation number of Fe, that is ion, from this compound is what? Is 3. So you call it ion 3. Ion 3 what? Oxygen will now what? We change to ide. Oxygen will change to oxide. Oxide. So the name of this compound is what? Is ion 3 oxide. Ion 3 oxide. That is for transition element. But if it is what? If it is for group 1 to 3 elements, if you are talking about group 1 to 3 elements, you don't need to name the oxidation number of that metal. So metals, group 1 to 3 metals are what? You don't need to name their oxidation number when you are talking about what? Group 1 to 3 metals. Now let's take another example under a ionic compound of transition elements. Another example, let's look at MnO2. MnO2. Mn is what? Is a chemical symbol for manganese. Mn is a chemical symbol for manganese. Manganese. So what are we going to call it now? You name this what? You name it fully. Manganese what? Manganese. So let's calculate the oxidation number of what? Of Mn. Calculate the oxidation number of manganese. Let's calculate the oxidation number of manganese. So you will make manganese unknown. Then the charge on oxygen is minus 2. Minus 2 times 2. Minus 2 times 2 will give me minus 4. So therefore, Mn equal to 0. So Mn equal to, move this minus 4 to this side, we change to plus 4. The oxidation number of manganese from MnO2 is what? Is 4. So therefore, you write what? You write the oxidation number of that as manganese 4. So manganese 4 what? Oxygen will change to oxide. So manganese 4 oxide. So the name of this compound is called manganese 4 oxide. Manganese 4 oxide. So let's take another example. So let's look at these two compounds of copper, CuO and Cu2O and CuO. Let's name the first one, that is Cu2O. Cu2O. Then Cu is the chemical symbol for copper. Cu is the chemical symbol for copper. So you name copper fully. You name copper fully, followed by the oxidation number of copper from this compound. You name the oxidation number of copper from this compound. So make copper your unknown. 2 times Cu will give me 2 Cu. Then the charge on oxygen is 2 minus. So minus 2 times 1 oxygen will give us minus 2 equal to 0. Then make copper the subject of the formula. Cu2 equal to plus 2. By the time you move this minus 2 to this side, then divide both sides by 2. 2 cancel 2. Cu will now be equal to 2 here 1, 2 here 1. That's plus 1. So the oxidation number of copper from this compound is 1. So we call this copper 1. Copper 1 what? Oxygen will change to what? Oxide. So copper 1 oxide. Copper 1 oxide. Then let's name Cu. Let's name Cu. They don't have the same name. CuO. CuO. Then copper is a transition element. So name copper fully. Then followed by the oxidation number of copper from this compound. So what is the oxidation number of copper? So copper is unknown now. Then the charge on oxygen is 2 minus. So minus 2 times 1 oxygen, that's minus 2, equal to 0. Then Cu equal to, move this minus 2 to this side, we change to plus 2. So copper what? Copper 2 what? Oxide. Copper 2 oxide. So that's the name of that compound. That is how to name a ionic compound of what? Of transition elements. That is the binary compounds of transition elements. Then let's move to naming of covalent compound. Binary compound of what? Of covalent compound. So B is naming of covalent compounds. So what are covalent compounds? Covalent compounds are compounds of non-metals. Compounds of non-metals. So when two non-metals combine together, we call this what? A covalent compound. A covalent compound. So to name what? A binary covalent compound, you name the first element fully. Then followed by the oxidation number of the second of that first element. You name the first element fully, followed by the oxidation number of that element. Then the second element will change to what? We now change to ide. So let's take for example covalent compound, that is combination of what? Two non-metallic atoms. Let's take nitrogen is a non-metal, then and oxygen, NO2. So what are we going to call NO2? Nitrogen is a non-metal, oxygen is a non-metal. Why? Nitrogen is in group 5. So group 5, 6 and 7 are what? Are non-metals. Group 5, 6, 7 are non-metals. So nitrogen is in group 5. Nitrogen is in number 7. So it is 2:5. So it is in group 5. Oxygen is in number 8. That's 2:6. It is in group 6. So group 5, 6 and 7 elements are what? Are non-metals. This is the combination of what? This is the combination of two non-metallic atoms. So the first atom will be named fully, followed by the oxidation number of this atom. It shows that you have to calculate out the oxidation number of this atom from this compound. So we are going to name the first atom fully, which is what? Nitrogen. Nitrogen what? You calculate the oxidation number of nitrogen out. So my nitrogen is unknown. What's the charge on oxygen? That's 2 minus. So minus 2 times 2 will give me minus 4, equal to 0. So therefore N equal to, move this minus 4 to this side, we change to plus 4. So the oxidation number of nitrogen from NO2 is what? Is 4. You call this nitrogen 4. What? Then the other elements will what? We change to ide. So oxygen will change to oxide. So you call it nitrogen 4 oxide. Nitrogen 4 oxide. So let's name another compound of nitrogen. Let's name another compound of nitrogen. Nitrogen oxide. N2O. N2O is totally different from NO2. So they are not the same. So let's see how we are going to name N2O. Then this is the combination of two non-metallic atoms. So you name the first atom fully, which is what? Nitrogen. Nitrogen. Then calculate the oxidation number of nitrogen from this compound. How many nitrogen do we have? 2. 2 times N will give us 2N. Then what is the charge on oxygen? That's 2 minus. So minus 2 times 1 oxygen, that is minus 2, equal to 0. Equal to 0. Now, make N the subject of the formula. That's 2N equal to, move this minus 2 to this side, we change to plus 2. Then divide both sides by 2 to get N. So my N will be equal to 2 here 1, 2 here 1, plus 1. So the oxidation number of nitrogen from N2O is what? Is 1. So we call it nitrogen 1 oxide. Nitrogen 1 oxide. Let's take another example. Let's take another example. This is the combination of what? Of chlorine, of carbon and oxygen. C is the chemical symbol for carbon, while O is the chemical symbol for oxygen. So let's name. We are going to name the first atom fully, which is carbon. Then we calculate the oxidation number of carbon out of this compound. So let's calculate carbon. Carbon is unknown. Then the charge on oxygen is minus 2. So minus 2 times 2, that's minus 4, equal to 0. So therefore, C equal to, move this minus 4 to this side, we change to plus 4. So the oxidation number of carbon from this compound is 4. So we call it carbon 4. Carbon 4 what? Then oxygen will change to what? Ide, oxide. Carbon 4 oxide. Carbon 4 oxide. Let's take two more examples. SO2. We are going to name SO2 and SO3. So they are compounds of what? Compounds of sulfur. They are compounds of sulfur. Let's see how we are going to name the first one. SO2. S is a non-metal. S is a non-metal because it is in number 16. Sulfur is in number 16. The first shell we carry 2. Then the second we carry 8, followed by 6. 2 plus 6, 2 plus 8 plus 6 will give you 16. Then the number of valence electron is what? Is 6. Then elements with 5, 6, 7 valence electron are non-metal. So therefore, sulfur is what? Is a non-metal. Then oxygen is also a what? Oxygen is also a non-metal. So when we are talking about two what? Combination of two non-metallic atoms, the first one will be named fully. So let's name the first one. Then S is what? Is sulfur. Followed by the oxidation number of sulfur. So you calculate the oxidation number of sulfur out. So sulfur is my unknown. The charge on oxygen is minus 2. Minus 2 times 2 will give me minus 4. So equal to what? 0. S equal to, bring minus 4 to this side, we change to plus 4. So the oxidation number of sulfur from this compound is what? Is 4. So we call it sulfur 4. Sulfur 4 what? Oxygen changes to ide, oxide. Sulfur 4 oxide. Then the other compound, which is SO3. Then you name what? Sulfur fully, that's sulfur. Then you calculate the oxidation number of sulfur out of this compound. So sulfur is my unknown. The charge on oxygen is -2. -2 times 3 will give me -6, equal to 0. Equal to 0. Then therefore S equal to, move this -6 to this side, that will be +6. So the oxidation number of sulfur from this compound is 6. You call it sulfur 6. Then oxygen changes to oxide. So sulfur 6 oxide. That is all about what? Naming of binary compounds. Naming of binary compound. In my next video, I'm going to explain naming of polyatomic compounds. Naming of polyatomic compounds. If you like this video, don't forget to subscribe to Royal Learning channel. Share this video with your friends and comment. See you in my next video. Bye.